Hi, and welcome to Module 7, which is the first of 3 modules on algebra review. So the first one, we're going to mostly do some definitions that will help us do the remaining 2 and actually practice a little bit. And again, these 3 modules definitely need practice. These are not things you can just watch and get something out of. You have to go and try to do these things yourself, do the algebra yourself to get some practice in it. So I'll go a couple examples here in the lectures, but mostly it's important to do practice problems, make sure you can do that stuff, do the problem sets for this particular video lecture, check your answers, do other problems. The good news is easy to make up problems. You just throw numbers together and add or subtract, as we'll see. Okay, so first those some definitions. A few things that will help us do the actual examples later. First, relatedly to these examples, are some other types of expressions you need to know. Percentages you've seen before, right? Percentage sign looks like that. So 5% means 5% of a total. 5% is the exact same thing as 1/20. A percent in general is the same thing as that amount of something. So if you take a percent and multiply it by 0.01, you get 0.05. That's how much of something. Percents and proportions are very closely related. This is a proportion. That times 100% equals a percent. So proportion, let's change color, percent. The white one over here is proportions. The red one is percent. Okay. Proportion and percent both tell you the same thing. It's how much of the whole, which is 100%, or 1. So the whole here is 1. The whole here is 100%. How much of that you have. It can be less than 1 if you have less than the total, or more than 1 if you have more than the total. For instance, 150% is the entire thing plus an additional half of that thing. So if you had a pizza, 100% of the pizza would be the entire pizza. 50% of the pizza is the shaded region, and 150% of the pizza is a pizza plus half a pizza. That's a percentage. Proportions would be 1.5 instead of 150%, but they're the same thing more or less. You deal with these a lot. Ratios we've already talked about. A ratio is just any number over another number. We talked about it in the context of two integers that made a rational number, but really a ratio is any number divided by another number. You can write it like this, or we can write it like this. We're looking at odds ratios. This is a little confusing. We already said the colon could be a such that. Again, some of these expressions, some of these notations are used for more than one thing. You have to understand via context. Usually the context will be pretty clear. If this is looking at a ratio, at a ratio, it won't be such that. And you won't see a ratio stuck in the middle of a set definition. Again, these things have been evolving for a long period of time, so we don't always know exactly. We can't always force everything to be exactly clear. Sometimes there's more than one definition for the same piece of notation, and sometimes there's more than one piece of notation for the same definition. What can you do? Okay, so that's a ratio. Two different ways of writing ratios. Ratios help you compare two things, right? So if x is bigger than y, the ratio will be bigger than 1. If x is smaller than y, it's smaller than 1. If x is smaller than y, the ratio is less than 1, and x is smaller than y. And if x is the same as y, then the ratio is 1. So it can be bigger, smaller, or the same. And I'm going to make mistakes like that. I learned early on in this process that if I stop every single time I say something wrong, I would never ever produce this video series. So I apologize, and I will fix my mistakes quickly. Okay, so this is a ratio. You can think of other ways of comparing two things. So for instance, you can do a proportion. So if you have two numbers, x and y plus y is the sum, it's the total, then x over x plus y is the proportion of the total, which is taken up by x. And this is a proportion. If you multiply it by 100%, it's a percentage. You can also look at percentage change to see how much you've changed from one point to another one. So you could do, so if there's the new x, put a subscript for new, minus the old x, divided by the old x, tells you how much you changed from the old one. Right, so if you started off at 1, you went to 2, then it's 2 minus 1 over 1, or 1, so you've changed it by 100%. You've changed your original thing by 100%, or a proportion of 1. Again, portions and percentages are the same exact thing, just one's expressed in terms of percents and is 100 times the proportion. Whatever you feel more comfortable saying, that's what you should say. That's portions and percentages. Again, there's more ways of writing these things, but they're not terribly exciting, and you'll get a hang of them pretty quickly. You can look at rates as well, which is the rate of time in which something happens. And there, the rates can vary. This is the kind of thing you learn more about in, say, a research methods class. Won't come up at all in this course. But rates are the relative portion of time that something is happening. And the tricky part there is to make sure you understand what the base rate is. Is it per year, per 100 years, or so on? Couple more things to end up this one. We already talked about most of them. Equalities will help us equate things, right? So we'll be trying to be solving equations like this. X equals plus 7 squared times y minus 2. We might want to solve for y, right? The equals tells us these two things are the same. So when we can move things around, treating them as the same, which we'll see next module. We also can have inequalities. Here, x and y are variables, like we talked about before. Here, x is greater than or equal to 7y plus 2. And we've already discussed the inequalities. Greater than or equal to, greater than, less than or equal to. Those are the major inequalities, and you can move things around there too. We're going to deal with two different topics here in module. In the next module, we're going to deal with solving equalities, and then we're going to deal with simplifying inequalities, and also looking at solutions that are less easy than the solutions we'll look at in the next module. That's pretty much it. Just a couple more small things. If you have a variable x to the first power just means you take x once, which means x to the first power is x. X to the 0th power means you have no x's at all. That leaves you with the identity. So anything to the 0th power is 1. Something to remember there. And again, 1 over 0 is undefined. Anything over 0 is undefined. And that's pretty much it. So thank you, and next module again will be solving equalities. Thanks.